Hello, grade 8. This is Mrs. Lopez, and we are in lesson 9 of our module 1 for grade 8. Today, we are learning the new words called scientific notation and the whole new notation that really is um, out there for you to make all of our lives, really easier. You did some scientific notation even before you knew what it was. When in lesson 8, we were working on writing a number as a single digit multiplied by the power of 10, we were actually using scientific notation. So, what is scientific notation? It says here a positive finite decimal s is said to be written in scientific notation if it is expressed as a product d times 10 to the nth power, where d is a finite decimal so that it's greater or equals to 1 but less than 10, and n is an integer. The integer n is called the order of magnitude of the decimal d times 10 to the nth. So what really is scientific notation is when you have a number, let's say 3,000, written as a single digit that is more or equals to 1 or less than a 10. So we can have 3. We cannot have 30 because it's more than a 10. Or we cannot have 0.3 because it's less than a 1. So it's 3 times 10 to the third power. That is scientific notation. The most important thing here is that this number right here, it has to be greater or equals to 1 and less than a 10. If that is not the case, it means that the number is not written in scientific notation. So look at example 1. The finite decimal 234 and 567 thousandths is equal to every one of the following. So we can look at this number. So the same digits, but the decimal is after the 2, multiplied by 10 to the second. That means we would multiply it by 100, and now where the decimal would be after the 4, just like here. We have a decimal after the 0 and multiplied by the power of 3, 10 times 3, 10 to the power of 3. So the decimal, again, is after the 4. We have 23 times 10, because if I multiply by 10, my decimal will be after the 4. We have 234 and 567 thousandths times 10 to the 0th, because we know it's a 1, and this number is by itself. We have a whole thing here without any decimals, and multiply by 10 to negative third, because that is thousandths place, and so I will have to move my decimal to the left 3 times to move it to bring it back to standard form. Or I have a big number like this with 3 more zeros times 10 to negative 6. And if I bring it back to standard form, I will have 6 units to the left decimal. So it's again after the 4. So this number that is given to us is equal to all of these 6 variations of it. However, only one, the first, is a representation of this number in scientific notation, because the whole number is greater than 1 or equals to 1 and less than 10. So let's look at this one. A whole number is a 2. Whatever comes after it is decimal numbers, and we don't have to worry about them, but the whole number is 2. It's more than a 1 and less than a 10. And we are multiplying it by the power by 10 to the power of 2, because our decimal has to be in the original spot after the 4. Okay, so let's see if the other numbers are written in scientific notation. So first one, we have 1 and 908 thousandths times 10 to the 17th. We have a whole number that is 1, and it is equal to 1 multiplied by 10 to the power of 17th. So yes, it is written in scientific notation. Exercise 2, the whole number is 0. It's less than a 1, so no matter what comes after it, we already know that it's written in not scientific notation. So now the whole number is less than a 1. Exercise 3. Whole number is 7. It's more than a 1 but less than a 10, so that works, and we have multiplied by 10 to the power of 32. Yes, it is written in scientific notation. Let's look at exercise 4. A whole number is 4. That is good. It's more than a 1, less than a 10. However, we have an addition here, not a multiplication sign. So that is not a scientific notation. They're just adding 10 to the power of 7, not multiplying by it. So no, addition instead of multiplication. Okay. Exercise 5, the whole number is 18. It's more than 10, so that is not working for us. So no, the whole number is more than a 10. And exercise 6, 8 is a whole number. It is more than a 1, less than a 10, multiplied by the 10 to the power of negative 11. Yes, it is written in scientific notation. So all you need to know from here is the scientific notation is a notation where we have a whole number that is more than a 1 or equals to 1 and less than a 10 multiplied by 10 to the power. Oh, another one that I wanted to show here, yes, it is 18, so yes, it is not in scientific notation. And also it's multiplied not by the 10 to the power. So that is not working out for us either. We are moving on, and we are on example 2. So we are going to just read through. There are a couple examples. We are going to read through and try to understand what's happening here. Let's say we need to determine the difference in the population of Texas and North Dakota. In 2012, Texas had a population of about 26 million people, and North Dakota had a population of about 6 and 9/10 times 10 to the fourth power. We begin by writing each number in scientific notation. So for Texas, we have 26 million people, and we need to write it in scientific notation. So we are going to put 2.6. The reason why we are putting 2.6 is because we have to have our whole number more than a 1 and less than a 10. So we cannot use 26. We cannot use 2.26. So the only way we can write this number is 2.6 because the whole number is more than a 1 and less than a 10. And we are multiplying it by 10 to the power. So let's see how many digits I have after the decimal. 1, 2, 3, 4, 5, 6, 7. So it's 10 to the 7th power. North Dakota, it already has our scientific notation, which is 6 and 9/10 times 10 to the 4th. To find the difference, the word difference tells us that we need to subtract. So it says we need to determine the difference, right? The difference is subtraction problem. So we are going to subtract one from the other. We are subtracting the Texas population and North Dakota. To compute this easily, we need to make the order of magnitude exponent of 10 of each number equal, because I cannot take away 10 to the 4th from 10 to the 7th. It doesn't work that way because the numbers are different. So we need to make sure that the order of magnitude, this exponent on top of the 10, is the same. Okay? Each number must have the same order of magnitude and the same base. When the number have the same order of magnitude and the same base, we can use the distributive property to perform operations because each number has a common factor. And we learned about distributive property last year. Specifically for this problem, we can rewrite the population of Texas so that it is an integer multiplied by 10 to the 4th and then subtract. So they're taking this problem 2.6 times 10 to the 7th minus 6 and 9/10 times 10 to the 4th, and they're changing this 10 to the 7th into 10 to the 3rd times 10 to the 4th. because by the rule of multiplying like bases with exponents, we would have to add exponents, and we will get 3 plus 4 is 7. So they're changing 10 to the 7th into 10 to the 3rd times 10 to the 4th. So we have 2.6 times 10 to the 3rd times 10 to the 4th minus, and they're leaving this one behind, 6.9 times 10 to the 4th. Now, they're combining 2.6 times 10 to the 3rd, and they're writing it in standard form. So they're multiplying 2.6 by 1,000, and they're moving the decimal over 3 times to the right. So that becomes 2,600 times 10 to the 4th. The reason why they have parentheses here is to show you that they're actually multiplying 2 and 6 tenths by 1,000 right here. Okay, so this number turns to this number. So now we have both numbers, both tens, with the power of 4. Now, using distributive property, think about it as last year when we had 2 times 3 plus 4. We knew that we could multiply 2 by 3 and add 2 times 4. So what it's going to look like is 2 times 3 plus 2 times 4. The same thing goes for subtraction. If I had 2 multiplied by 3 minus 4, I would still multiply 2 by 3 and 2 by 4 and subtraction sign in between. So I'll have 2 times 3 minus 2 times 4. Okay, so here I have that part. This number times this minus this number times the same number as this one. That means that 10 to the 4th power we can put outside the parentheses. So, and this one. So when we do the opposite, we would multiply 10 to the 4th by both numbers inside the parentheses, and it's going to be the same thing as here. So what they did, they took the 10 to the 4th, which is the same factor for both of these, and they're taking it outside the parentheses using distributive property. Now they're doing the computation. 2,600 minus 6 and 9 tenths. They did that, and that is multiplied by 10 to the 4th. And after that, they're just moving the decimal 4 spaces to the right when they're multiplying by 10,000. 1, 2, 3, 4. And that is the final answer. I know it looks a little bit complicated, but when we get to learn more about it, when we get to practice, it's going to be a lot easier. Okay? Example 3. Let's say that we need to find the combined mass of 2 hydrogen atoms and 1 oxygen atom, which is normally written as H2O or otherwise known as water. That you probably know from science. To appreciate the value of scientific notation, the mass of each atom will be given in standard notation. So 1 hydrogen atom is this much of a kilogram. So that's a big, big number that I don't even know how to say. And 1 oxygen atom is this much of a kilogram. To determine the combined mass of water, we need the mass of 2 hydrogen atoms and add 1 oxygen atom. Imagine if you had to do it by just multiplying this number by 2 and adding this number, and it's going to be so much work, and you will definitely forget 1 and 2 zeros in between. So first, what we need to do to make it easier for ourselves is to write each number in scientific notation. So hydrogen atom we can rewrite as 1.7, and again 1.7 is because the whole number has to be equal or more than a 1 and less than a 10. So it's 1.7, and then we are looking at how many digits I have before the decimal, and because the number is so small, we are going to have a negative exponent. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So the exponent of 10 is negative 27. because if I were to put it back, I would have to move my decimal over to the left to make it smaller. Oxygen atom is 2.7, so I'm going to put decimal right here. And again, we would count how many zeros or digits, rather, we have before the decimal. So again, it's going to be a negative exponent because the number is so small, and it's going to be 10 to the negative 26. Okay, now since it's H2O, we need 2 of the H's. So we will have to multiply 2 by 1.7 times 10 to negative 27. Since it's multiplication, all I need to do is to multiply 2 by 1.7, and it's going to be 3.4. And I'm multiplying it by 10 to the negative 27th power. The equation for 2 hydrogen atoms and 1 oxygen atom will be the number that I got for the hydrogen, and I'm adding the number for the oxygen, which is this one. How do I add these numbers? So again, if I'm looking at power of 10, I see that the powers are different. Means I will not be able to do anything with them just yet because it's not just multiplication, right? I will not be able to add or subtract exponents. I need to make sure that the order of magnitude is the same. So they rewrote this problem down here, and they're changing negative 27th power into kind of not changing, but rewriting, decomposing that 10 to negative 27th to 10 to the negative 1st times 10 to the negative 26th. Because if I combine negative 1 and negative 26, I will get negative 27. After they decompose these two, they're multiplying 3.4 by 10 to negative 1 to get rid of this number. So we are moving our decimal over once, and because it's negative, to the left to make the number smaller. So you got 34 hundredths times 10 to the negative 26th, and you're adding whatever is left, plus 2.7 times 10 to the negative 26th. So now I have 10 to the negative 26th and 10 to the negative 26th that I can put outside my parenthesis and combine the two leftover numbers. So 34 hundredths plus 2 and 7 tenths is going to be 3.4 hundredths, 3 and 4 hundredths, times 10 to the negative 26th power. Okay, so that will be the combined mass of 1 atom of water. Okay. Okay, let's see. Next one is, let's see. Oh, here, what they're doing here, they're just changing negative 26th power into negative 27th power. So they're actually decomposing 10 to the negative 26 into 1 times 10 to the negative 27th, because 1 plus negative 27 is negative 26. So they're doing it the other way around, right? So they're changing a smaller number into a bigger number. They're multiplying 2.7 by 10, and it is 27. So now you have negative 27th power for both of these, which we are taking outside the parenthesis and adding whatever is left. So you get 30.4 times 10 to the negative 27th. But that is not scientific notation because 30 is more than a 10. So we need to move our decimal over once to the left, making the exponent a little bit bigger, right? So since we are moving it, it's going to be negative 26. Okay, so let's go ahead and start practicing how that all works. The table below shows the debt of the 3 most populous states and the 3 least populous states. We don't know really what statistics is given to us from what year, but that's what we are going to work with. So all of these numbers are written in standard form. First, what we want to do is we want to write all of these answers in scientific notation. So 407 billion is going to be written as 4 and 7 hundredths because our whole number has to be more than 1 and less than a 10, multiplied by 10, and we are looking at how many digits I have after the decimal. So I have 9, 10, 11 times 10 to the 11th power. Sorry. I'll just turn the light on. Okay, sorry about that. Okay, so next one is 337 billion. We are going to move our decimal to after the first three. So it will be 3 and 37 hundredths, again, because 3 is more than a 1 and less than a 10. And we are multiplying it by 10, and we are counting how many digits I have after the decimal. It's also 11, so 10 to the 11th. Okay, then we have 2 and 76 hundredths times 10, and again we have 11th power. North Dakota has 4 times 10, and after the 4 we have 9 digits, so 10 to the 9th. Same goes for Vermont, exactly same number, 4 times 10 to the 9th. And same goes, well, almost goes for Wyoming. This one is 2 times 10 to the 9th. 2 times 10 to the 9th. Okay, now let's look at population. We worked with the dead. Now we are working at population of 2012. That's what it is. So we have 3 and 8 tenths times 10, and we are counting how many digits we have after the 3, and that is 7. Next one, 1.9, 1 and 9 tenths, again times 10 to the 7th. Next one, 2 and 6 tenths, again 7, 2 and 6 tenths times 10 to the 7th. Then I have 6 and 9 tenths, and I have now 5 digits after the decimal, so times 10 to the 5th. 6 and 26 hundredths, 6 and 26 hundredths times 10 to the 5th. And I have 5 and 76 hundredths times 10 to the 5th. Okay, so our table is filled out. Now we can work with those scientific notation numbers, with numbers written in scientific notation. What is the sum of the debts? So we are looking for the debts of the 3 most populous states. Express your answer in scientific notation. So we are looking at the debt, and we are looking at our scientific notation. Most populous states are the first 3, so we are going to combine their debt. So we have 4 and 7 hundredths times 10 to the 11th plus 3 and 37 hundredths times 10 to the 11th plus 2 and 76 hundredths times 10 to the 11th. Okay, notice that all of these 3 terms have 10 to the 11th power. So that we can take out of the parentheses and not to worry about it. So I can rewrite that as 4 and 7 hundredths plus 3 and 37 hundredths plus 2 and 76 hundredths, take it in parentheses, and multiply it by 10 to the 11th power. Because if I get to do the opposite, I'm going to multiply that 10 to the 11th power by all of these 3 numbers inside the parentheses. Okay, so now what I need to do is to combine all of their debt. Together is going to be 10 and 2 tenths. 10 and 2 tenths. And that we have times 10 to the 11th. Now let's look at our number. Is it written in scientific notation? No, it isn't, because the whole number equals to 10. and we cannot have that. We only can have a number that is more than a 1 or less than a 10. So we'll have to move our decimal over to the right, and it means we are dividing by 10, right? So it's 1.02, and since we are dividing by 10, we are multiplying by 10 to the negative first power, right? Sorry, to the first power, and then that is times 10. So I'm rewriting this number, 1 and 200 times 10, because if I do the opposite, I will move my decimal back here, and that is first power. And then we have times 10 to the 11th left. So now I can use the multiplication rule for like bases. I'm going to add these two exponents, and I will have 1 and 2 hundredths times 10 to the 12th. So that is the combined debt for all three most populous states. Let's look at the B problem. We are doing the same thing. We are looking for the sum of the debt, but for the three least populous states. So we are adding 4 times 10 to the 9th plus 4 times 10 to the 9th plus 2 times 10 to the 9th. So I'm going to put that 10 to the 9th because I have it in all three cases. I'm going to put it outside of the parentheses, and I will have 4 plus 4 plus 2, and that is all multiplied by 10 to the 9th. Okay, so now what I need to do is to add 4 plus 4 plus 2, which is 10, times 10 to the 9th. So again, I'm looking at this number and thinking, is this number written in scientific notation? No, it isn't, because my whole number is equal to 10. We cannot have that. Our rule is that we have to have a number that is more or equals to 1 or less than a 10. So we are going to change this and decompose it into 1 times 10 to the first power. Because if I do that, I will get my 10. 1 times 10 is 10, right? And I'm going to multiply it by 10 to the 9th. By the multiplication of like bases now, because I have 10 and 10, I'm going to add the exponents. 1 times 10 to the 10th power. Okay, now we're done. This number is written in scientific notation. We are moving on to number 6, to problem C, and it says, how much larger is the combined debt of the three most populous states than that of the three least populous states? Express your answer in scientific notation. So now we are looking at the two numbers that we got. So we have 10 and 1 and 2 hundredths times 10 to the 12th. So I'm going to write that. 1 and 2 hundredths times 10 to the 12th. And I'm subtracting, since to find out how much larger, not how many times, but how much larger. So we are going to subtract to find out the difference. And we are subtracting 1 times 10 to the 10th. 1 times 10 to the 10th. Okay, so here's the thing. I have the same base, but I have different exponents. So I cannot put either 10 to the 12th or 10 to the 10th outside the parenthesis, because it has to be the same. So what I'm going to do, I'm going to decompose that 10 to the 12th into 10 to the 10th plus times 10 to the 2nd. 10 to the 10th times 10 to the 2nd. So together it's going to be 10 to the 12th, right? And I'm going to rewrite the whole thing all together again. So I have 1 and 2 hundredths times 10 to the 10th times 10 to the 2nd minus 1 times 10 to the 10th. Now, I have 10 to the 10th and I have 10 to the 10th, so that is good. But I also have 10 to the 2nd. So that is not good. That is my obstacle right now. We need to get rid of it. So I'm going to apply that, and I'm going to multiply 1 and 2 hundredths by 10 to the second, which is 100, right? I'm multiplying by 100. When I multiply by 100, I'm moving my decimal twice to the right. So I will have 102 instead of 102. And I'm getting rid of that 10 to the second. And I'm writing times 10 to the 10th minus 1 times 10 to the 10th. So now we're having that 10 to the 10th that is the same, and I can now put it outside the parentheses. So I have 102 minus 1, and that whole thing is times 10 to the 10th. 102 minus 1 is 101. I'm going to write here so I can save some space. 101 times 10 to the 10th. Now, 101 times 10 to the 10th is not written in scientific notation because a whole number is way more than a 10. I need to make it more than 1 or less than a 10. So where should I put my decimal after the first one? So I need to decompose that into 1 and 1 hundredths times 10. And since I am going to multiply to get 101, it has to be 10 to the second power. And then times 10 to the 10th again. Now I can combine like exponents like bases, and I will have 1 and 1 hundredths times 10 to the 12th power. Now I'm done. That is my answer. So the combined debt of three most populous states is 1 and 1 hundredths times 10 to the 12th more than the combined debt of the least populous states. Okay. Now let's look at the population. What is the sum of the population of the three most populous states? So we are going to look back into our table, and we are looking at the three most populous states, and we are looking for the sum. So we have 3 and 8 tenths times 10 to the 7th, 1 and 9 tenths times 10 to the 7th, and 2 and 6 tenths times 10 to the 7th. So we just need to rewrite I'm going to just write it on the side so I remember. 1 and 9 tenths and 2 and 6 tenths, and all of that times 10 to the 7th. Okay, so I'm combining 3 and 8 tenths times 10 to the 7th plus 1 and 9 tenths times 10 to the 7th plus 2 and 6 tenths times 10 to the 7th. All of the powers of 10 are the same. So I can put 10 to the 7th outside the parenthesis. 3 and 8 tenths plus 1 and 9 tenths plus 2 and 6 tenths. All of that is multiplied by 10 to the 7th power. Okay, so when I combine these, I will get 8 and 3 tenths times 10 to the 7th. Is my number written in scientific notation? Yes, it is, because 8 as a whole number is less than 10. Okay. What is the sum of the population of the three least populous states? So we are going to go back again to our table and copy the numbers from our table for the three least populous states. So it's 6 and 9 tenths, 6 and 26 hundredths, and 5 and 76 hundredths, all multiplied by the 10 to the power of 5. Okay, so I'm writing 6 and 9 tenths times 10 to the 5th plus 6 and 26 hundredths times 10 to the 5th plus 5 and 76 hundredths times 10 to the 5th. Okay, I see that 10 to the 5th is the same for all of the three terms, so I can put it outside the parenthesis. I have 6 and 9 tenths plus 6 and 26 hundredths plus 5 and 76 hundredths, all multiplied by 10 to the power of 5. Okay, so when I add these three numbers together, I will get 18 and 92 hundredths times 10 to the fifth. Is my number written in scientific notation? No, because 18 is more than a 10. I have to break it down or decompose it into 1 and 892 times 10. And since I moved my decimal over, it has to be to the power of 1 once times 10 to the fifth. So now I can combine the exponents because it's all multiplication, and I will get 1 and 892 thousandths times 10 to the sixth power. Okay, number is written in scientific notation. That is our final answer. C. Approximately how many times greater is total population of California, New York, and Texas compared to the total population of North Dakota, Vermont, and Wyoming? Okay, so we are taking the population of our most populous states, and we are dividing it by the dividing it by the population of the least populous states. So we are taking 8 and 3/10 times 10 to the seventh and dividing it, because we need to find how many times greater, by 1 and 892 thousandths times 10 to the sixth. We had these problems before. We can separate these two into 8 and 3/10 over 1 at 892 thousandths, and we are multiplying it by 10 to the seventh over 10 to the sixth. So now I see this fraction, and this is also a division problem, that I can use my calculator and divide 8.3 by 1.892. When I do that, I will get 4 and 39 hundredths. That is approximately 4 and 39 hundredths times, and I'm subtracting exponents here by the rule of dividing like bases with the exponents, and I get 10 to the first power, or just 10. Is my number written in scientific notation? Yes. However, I can actually multiply by 10 because this is not a big power, and I can get 43 and 9/10 times. So the answer will be the population of California and New York and Texas is 43, almost 44 times greater than North Dakota, Vermont, and Wyoming. Okay. I think it's last exercise here before you get to the problem set. All planets revolve around the Sun in elliptical orbits. Uranus' furthest distance from the Sun is approximately 3 and 4 thousandths times 10 to the ninth kilometers, and its closest distance is approximately 2 and 749 thousandths times 10 to the ninth. Using this information, what is the average distance of Uranus from the Sun? Okay, so they're looking for the average distance. Let's review how to find average. If you are finding average of your grades, of your test grades, let's see, you had 3 tests with 97, 85, and 73 percent for all of your 3 grades. So what we want to do is we want to combine the 3 and then divide it by the number of tests you have. Divide by 3. Okay? That's how you find the average. So how do I find the average distance of Uranus from the Sun? So we know that its furthest distance from the Sun is this one, and the closest distance is this one. What I want to do is to combine the distances and divide by the 2 distances. Okay, so I'm going to write 3 and 4 thousandths times 10 to the ninth, and I'm going to add the other distance, 2 and 749 thousandths times 10 to the ninth, and I'm going to divide it by the 2 because that's what I'm adding. I'm adding two numbers and I'm dividing by 2. Okay, so we are looking at the power of 10. The power of 10 is the same. I can put it outside the parentheses. So I'm going to write 3 and 4 thousandths plus 2 and 749. It is all multiplied by 10 to the ninth, and I'm going to divide that by 2. All right, so when I add these two numbers together, I get 5 and 753 thousandths times 10 to the ninth. I'm dividing that by 2. Notice that 10 to the ninth does not have anything here on the bottom. So all I need to do is to divide this number by this number, and that will be times 10 to the ninth. I will get 2 and 8765 times 10 to the ninth. So on average, what it means, this number means, is on average, the Uranus is 2 and 8,765 ten thousandths times 10 to the ninth kilometers from the sun. Okay, so that was a long lesson, and we will get to practice quite a bit on that addition and subtraction. Your homework is the problem set. It has only 2 problems, and that should be pretty easy if you understand the lesson. If you don't worry about it. We will go over it in class. I wish you good luck, and I will see you in class.